Welcome back. So today we're going to be working with area of circles and area of sectors. So we're going to be starting on the left-hand side with area of a circle. So if you want to go ahead and open up your foldable, we're going to be working on the left. And I will zoom in on this so that you can see it a little bit better. So like I said, we're going to start with the area of a circle with our equation for area of circle. So this should be some review. If not, hopefully this is pretty simple. We're just going to be plugging in some information here. So area for a circle, we're going to use A for area equals pi times r squared. Remember, r is your radius. All right, so these examples here, like I said, we're going to be taking this equation that we just wrote and just plugging in some information for the variables. So for this first one, it says find the area of the circle with a radius of 4 centimeters. So we want to find area. A equals pi. They told us the radius is 4 centimeters, so we're going to put 4 in for r, and then that's squared. Okay, so all we have to do here for this one is we're just going to square the 4, so that becomes 16 pi. We usually put the number in front of a variable, so we look at the pi similar to what we look at it when we're talking about x or y or z or things like that. So we put those numbers in front. So we have 16 pi. We're going to leave it in terms of pi, and we're going to add a label. For this one, it's centimeters squared, since we're dealing with area. Okay, so that's all we do on that one. Let's move on down to the next one. It says find the area of the circle. This time they put everything in the picture here. So they tell us the diameter equals 11, but we need radius. Radius is half of the diameter, so our radius equals 5.5. So again, we're going to take that equation, A equals pi r squared, and we're going to plug in what we know. We know that r is 5.5, so this becomes A equals pi times 5.5 squared. So again, we're going to square 5.5. So if you want to use your calculator for that, that's fine. A equals 5.5 squared is 30.25. And then we're going to leave pi in there. And then we need a label. Again, we have centimeters here. So centimeters squared would be our label. Okay. Let's go ahead and move down to this next one. This time it says we're going to find the diameter of a circle whose area is 96 pi. Okay, so this time the 96 pi is going to go in for the capital A. So 96 pi equals pi r squared. Okay, so from here we're going to try to solve for r. So we're going to divide by pi on both sides. So now pi crosses out on the left, pi crosses out on the right. So we're left with 96 equals r squared. In order to find r, we're going to have to square root both sides. So I need to find out what 96, the square root of 96 is. So I'm going to find my factor pairs. And remember, when we're simplifying radicals, we're looking for perfect square factor pairs. That's like 4, 9, 16, 25, 36, those kinds of numbers. So for this one, 16 will go into 96 evenly. It goes in 6 times. So to break down 96, I get square root of 16 and square root of 6. Square root of 16 is a perfect square. It's 4. Square root of 6 cannot be broken down anymore, so that's going to be square root of 6 there. So then over here on this side, we're going to put 4 square root of 6 equals r. But it asked me for diameter. So I'm going to take 2 times 4 square root of 6 to get my diameter. 2 times 4 gives us 8. So that's 8 square root of 6 equals diameter. And then we also need a label, centimeters. So don't forget those labels. Next, what is the area of a semicircle whose diameter is 8 meters? Okay, so if diameter equals 8, radius is going to be half of that, which is 4. Semicircle means half of a circle, so we're going to take area equals pi r squared, and then we're going to cut it in half, or divide by 2. So plugging in the things that I know, a equals pi r is 4, so this is going to be 4 squared over 2. So then we're going to simplify 4 squared. 4 squared is 16, so this becomes 16 pi over 2. 16 divided by 2 is 8, so area equals 8 pi. And then we need a label here again, meters squared. It asked us for area. We have found the area. All right, one more in this section. So this last one, we're going to be working with these concentric circles again, and we want to find the area of that shaded region. Okay, so in order to do that, we're going to take this big circle and we're going to find the area of that. So the area of the large circle is going to be pi. The radius of the large circle is 5, so pi 5 squared. To figure out just the shaded piece, we're going to cut this center part out, kind of like you would a donut. So we're going to subtract the area of the small. So subtracting pi, the radius of the small one is 3, so 3 squared. All right, so then moving on here, we're going to simplify these exponents. So this becomes 25 pi minus 9 pi. 25 minus 9 gives us 16, and we still have pi. So the area equals 16 pi, and then our label, those two little hash marks mean inches, and we're going to square that. So 16 pi inches squared for this shaded region. All right, let's go ahead and move on to the other side of our foldable. This is our sectors, area of a sector. So for this side, we're going to start at the top. We're going to fill in some information there. The sector of a circle is a region bounded by 2 radii. Radii is radii, and their intercepted arc. Okay, so it's this shaded piece. It's that slice. It's like a slice of pizza. Then we're going to find our formula here. So the formula for the area of a sector is similar to what we talked about with arc length. It's a fractional piece of the whole area. So if you think back to when we were talking about arc length, our fractional piece, we take the measure of the arc divided by 360, that gives us our fractional piece, times, since we're finding the fractional piece of the area, we're going to multiply it by area, so pi r squared. Okay. All right, so let's do some practice problems with this formula. So the first one that we have, it says we're going to find the area of the sector ABC if its intercepted arc is 40 degrees and the radius is 8 centimeters. So we're going to take area equals 40 is our arc over 360 times pi, the radius is 8, squared. Okay, so now from here, a couple things that I need to do. Number one is work with my exponents. So 8 squared, this becomes 64 pi. 40 over 360. We know they have a 10 in common, so we can get rid of those zeros. And then I can still simplify 4 over 36. That'll come down to 1 over 9. From here, I'm going to multiply 1 times 64, so I get 64, and I also have the pi with that 64, so 64 pi over the 9. So now I'm going to punch that into my calculator and find out what 64 over 9 is to the nearest tenth. We're going to approximate to the nearest tenth on this one. So I got 7.1, and we still have pi there, so 7.1 pi. And then my label, centimeters. Since it's an area, it's going to be centimeters squared. Okay? All right, let's look at the next one. Again, on the second one, everything is in the picture for us. So we're going to find the area of the sector. So A equals the measure of the arc, which is 66 over 360, times area, which is pi. R is 15, so 15 squared. So again, simplifying, we can look at our exponents first. This is 225 pi. And then we can also simplify that fraction. So simplifying that, 6 goes into both. So that's going to become 11 over 60 equals A. From here, I'm going to go ahead and multiply my 225 pi times my 11. So that's going to give me 2,475 over 60 pi. And again, I'm going to use my calculator here to come up with a decimal. This one actually ends up being a terminating decimal, so we're just going to put all the decimal places. I got 41.25, and then we still have pi on there. And this time they didn't tell us if this is centimeter, inches, feet, anything like that, so we're going to put units. So U squared for units squared. All right, let's keep moving here. We've got two more. The next one says we're going to find the measure of the central angle. Now, if you remember, we said the central angle is the same as the measure of the arc. Okay? We're going to find the central angle of a sector that has an area. So the sector's area is 12 pi, and the radius is 6 centimeters. Okay? So from here, we're going to fill out our equation. So that 12 pi we said was the area of the sector, so that's going to go on the left, equals the central angle, or the measure of that arc. Let's put an m in there for that, over 360, times the area of the circle, which is pi 6 squared, because the radius is 6. So simplifying my radicals, I end up with 36 pi, and then we still have this m over 360, and 12 pi on the left. From here, I'm going to simplify my 36 with my 360. 36 goes into 36 once. 36 goes into 360 10 times. So then I'm going to take 1 pi over 10, and I'm going to multiply by my reciprocal, which would be 10 over pi. On both sides, pi on the bottom crosses with pi on the top. 10 times 12 is 120. On the right, I have an m left. So 120 equals m. Now, if we think about what does m represent, m was the measure of our central angle. So what is our label there? Degrees. Last one. We're going to find the area of the circle if the area of a 40-degree sector of the circle is 34 meters. So 40 degrees, the area of the sector is 34 meters squared. So remember, the area of the sector goes on the left, so that's 34. 34 equals 40 over 360, and we want to find the area of the circle. So remember, when we're multiplying here, we're multiplying by pi r squared, which is the area of the circle. Okay, so we want to find that whole piece. So all we really need to move is just this fraction to the other side. So I'm going to simplify that fraction, 40 over 360. We actually had that up at the top on the first one that we did, and we said that reduced down to 1 over 9 times r pi r squared equals 34. So I'm going to multiply by 9 on both sides because that's my reciprocal. 9 times 34 is 306 equals pi r squared. And we know pi r squared is the area. So 306, my label is meters squared, equals area of the circle. Another way you can think about this is we said the sector is a fractional part of the whole. So if a fractional part, 1/9 of the circle is 34, we know it takes 9 pieces to make the whole circle, so then we would know, again, that we just need to multiply by 9. It gives us the exact same thing that we had in our formula here. Okay, well, that is all that I have for you today. Thank you, have a great day, and I'll see you in class.